Good morning, good afternoon. Welcome to a project called Urban Lux. That is a final project for the digital tools for generative building design, presented by Hisham and myself, Herman. The concept of our project is actually to develop an open source process that allows us to predict the amount of sun hours of an urban block extracted from OpenStreetMap. So the idea is to create a web-based process that allows us to predict sun hours in a building using a pix-to-pix model. So the workflow that we created is first we have created a synthetic urban block using Grasshopper that allow us to create different scenarios of urban blocks. Then we encode not just the geometric information, but also the heights of the building into an image. And then we also use Ladybug to predict the amount of sun hours that the surface of the ground will have received. We then fix this information into pix-to-pix. And then this allows us to then test it at any synthetic urban block and be able to predict the sun hours. And later on, we want to use this as a surrogate model to then be able to fit real urban fabric and urban blocks extracted from Mapbox and be able to predict directly from there. So first we started with a data set generation. So as you can see here on the left, this is the image that is generated with an urban generator developed in Grasshopper that allow us to parameterize the amount of plots, the minimum depth, the minimum heights, and so on. And also the heights are color-coded in order to pix-to-pix to be able to understand the relationship. And on the image on the right is the predicted image generated with Ladybug, that is amount of sun hours exposure on the surface. As you can see here, on this particular GIF, this is now a random generation of different samples. As I mentioned before, the color coding corresponds to the image, to the heights of the buildings on the left, and on the right, this is now the amount of hours exposed to the sun. We then proceed to generate 1,000 different images, that becomes a data set for this. And then we started predicting, implementing a pix-to-pix model. We started using anything from 1 epoch to a maximum number of 50 epochs. And then we managed to realize that after 10 epochs, we didn't have any major improvements on the model. We achieved a really good generation loss of 0.03. And as you can see here on the generation loss L1, we have started getting really good predictions and the graph started decreasing. Then we started to proceed by testing this. As you can see here on the 0.1 on the left input block. And this is now the test sample that we feed a block that it never saw before. We got the target result and we got all the way on the right, the predicted image. As you can see, the model was generalizing really well and the predictions were almost difficult to tell the difference between target and predicted. Then we did a further exercise and now we created completely synthetic and brand new tiles that we even distorted from the original data set. So the new test 0.1 is a tile that never saw before and we got the prediction was really good. But then on new test 0.2 and 0.3, we actually created completely almost dysfunctional urban blocks to be able to understand the capacity of the model to generalize it. I will pass it now to Hisham.
And because our final goal of this project is to predict sun hours for real urban blocks, we start to generate a different data set where we have another 1,000 images. And in this data set, we are generating urban blocks where we have different features. So on the next slide, we can see from this GIF that here we are including different rotation angles and different X and Y dimension for each iteration. And we also have different block sizes, width, and depth for each building. And with that data set, we start to train our model. So we also tried with different epochs and then ended up with using 10 epochs. And we have a generator loss L1 equal to 0.02. And the graph is also looking good because it's keeping decreasing by how many epochs we go for. So, and then the next slide, we started to test the model. So we have on the left the input colored block with different heights. And then in the middle, we have the target. And on the right, we have the predicted values. And then after testing the model, we started to go to Mapbox to generate our real urban blocks dataset. So we moved to New York City, where we have all of these buildings colored by the same color coding that exists inside Grasshopper. So here we have different clusters, different heights, and different colors for each building. And from there, we exported different 2D images to start testing them versus our previous model. And then we also tried to increase the accuracy of the previous model. So we trained our model one more time, but this time with 20 epochs. And it's kind of keeping the same generated loss value. So we have also here 0.02 value and a graph that keep decreasing from one epoch to another. And after training the model one more time, we started to test our exported images from Mapbox to predict the sun hours. And on the top part, we have our exported images. On the lower part, we have our predicted sun hours from our trained model.
So then,
and our test now, Herman.
Thank you. So then what we have done is we have then compiled all this information into a scientific poster that we go all the way from the concept of 01, the research and framework, where we portray idea and a project intentions. Then 02, actually we talk about the product methodology and the process we have taken. And then if we move to 03 is when we actually explains our very first trained model using the synthetic data and the different approach we have taken and the results. Then on the middle column 04, when we do a second attempt now with a new data set generated with more parameters and variance on the data, also with really good results. And then on 05 is actually when now we started using this as a surrogate model that we realized we got really good results, but now because of the extreme density of the urban fabric, we have also realized that we have to also start increasing the density of the pixels in order to be able to have better resolution. And then all the way now to the last part of the scientific proposal, that is 06, that talks about next steps and conclusions. So as an overall conclusion, we have realized that the use of machine learning can actually, on complex design and architectural processes, cannot just allow us to fast track the computational times, but also open the door to a completely new series of opportunities. Also, we have realized that the use of surrogate models can open the doors to great opportunities, but also when it's possible, it's much better to train the model directly using geographical data exported directly from OpenStreetMaps on this particular case. And as a future steps for our research is definitely to increase the qualitative and quantitative properties of our machine learning model, meaning not just by increasing or augmenting the size of variation of a trained data set, but also introducing further and more diverse urban typologies. So then our model can be implemented in a more variety of urban cases. Thank you.
Thank you.